Okay, so what you saw in the previous one was that the generating function we found was equal to f of x is 1 minus 2x over 1 minus 4x plus 3x squared. And there are a couple of ways we could get at this, but one is we could use partial fractions. So first we have to factor this. And I'm not saying that's easy. You have to look at it. You're probably used to factoring things where the x squared term comes first. In this one we're looking at something where the 1 term comes first. And so as you're factoring this, you're looking for 1 minus something, 1 minus something. And I'm using a trick from high school, which is where I'm looking at, this is positive, so the signs have to agree, and this is negative, so both of the signs have to be negative. Then I'm looking for two things that multiply to give me 3 and add to give me negative 4. And so that's going to look like 1 minus x, 1 minus 3x. So I'm going to do a partial fraction decomposition here. And that's a calculus 2 thing. I'm going to have a video about how to do partial fraction decomposition if you're rusty with it. But for now, let's just say, okay, we can jump to a partial fraction decomposition here. And we're going to be looking at a over 1 minus x plus b over 1 minus 3x. And after you do the partial fraction decomposition, you get answers for a and b. Let's see if we can do that quickly. So if I get a common denominator here, I'm going to have a times 1 minus 3x over 1 minus x times 1 minus 3x plus b times 1 minus x over 1 minus x times 1 minus 3x. And I'm claiming that this is equal to 1 minus 2x over 1 minus x, 1 minus 3x. Which means that the numerators better be equal. In other words, 1 minus 2x needs to be equal to a times 1 minus 3x plus b times 1 minus x. So if I plug in x equals 0 here, I get 1 minus 2 times 0 is equal to a times 1 minus 3 times 0 plus b times 1 minus 0. So I get the equation 1 equals a plus b. And if I plug in x equals 1, I get the equation 1 minus 2 times 1 equals a times 1 minus 3 times 1 plus b times 1 minus 1, which makes the b term go away, and so I get negative 1 equals negative 2a, which gives me that, what does that give me? Ah, of course. That gives me that a is equal to 1/2. And then I look, so a is 1/2. I go back here and I say, well, if 1 is a plus b and a is 1/2, then that means that b is also equal to 1/2. So now what I have is that my f of x is equal to one half times 1 over 1 minus x plus 1/2 times 1 minus 1 over 1 over 1 minus 3x. We know what these are, right? We know that these are equal to 1/2 sum over n greater than or equal to 0, 1 times x to the n plus 1/2 sum n greater than or equal to 0, 3 to the n, x to the n. And so what we're able to come up with is that this is equal to 1/2 plus, this is equal to the sum from n greater than or equal to 0 of 1/2 plus 1/2 3 to the n, and all of that is multiplied by x to the n. And remember, the entire point of this was that whatever we wound up with being the coefficient was equal to b of n. So we've solved our closed form recurrence. We've figured out that the closed form way to write this is b of n equals one half plus 1/2 times 3 to the n. And we can check that. We can look at our initial values and do a reality check on that. But that is our closed form solution that we found using generating functions.